Hello everyone. Today I'm going to be teaching you guys section 4.2, which is exponential decay. I'm going to use page 239, the classwork assignment that I gave last week as an examples, and just to clear up confusion because there was quite a lot on this assignment. So I'll start with number 9. Number 9 says f of x equals 2 times 1/5 to the power of x. So first thing is recognizing that this is decay and not growth. How do I know that? I look at this base right here, okay? The base, the number that has the exponent of x, is what tells us that it's going to decay. This number is a number between 0 and 1. It's greater than 0, but less than 1. It cannot equal 0. It cannot equal 1. It's a number between. Okay, so whenever you have a number between 0 and 1, that means that your graph, instead of a J, is going to kind of look like an L, if you want to think about it that way. So we start the same way we did in the previous lesson. All right, we're going to make a table of values, and we always want to use easy numbers. Really, we could use any numbers, but these numbers are going to give us a good picture of the whole graph. So we do the same thing. We're going to start by plugging in -2. Now this could be tricky because we have fractions this time, but not to worry. It's good to know how to do this without a calculator. So 1/5 to the -2 power, we take care of first. We want to make this positive. So we're going to flip the base. So 1/5 becomes 5/1, which is just 5. And now that 2 turns to positive. So now it's 5 to the 2nd power, which is 25. And 2 times 25 is 50. So that's our first value. All right. Now, what I would like you to do is pause the video and see if you could fill in the rest of the table yourself. I challenge you to not use a calculator. All right, now that you're back, let's see how you did. So now when you plug in -1, you should have gotten 10. 0 should have given you 2. 1 is 2/5. And 2 is 2/25. All right. Now, I'm going to erase this, and we're going to graph it. And one more time, pause the video. Practice yourself. See if you could have graphed this yourself and identify your domain and range. All right. Now, what I notice here is that indeed my numbers do go from high to low, which is what you want. Always check that. If you're dealing with decay, that should happen. And if you're dealing with growth, then it should be increasing. I also notice that all my values are greater than 0 on my y, so I'm going to use just the positive of my y-axis. I'm going to make my y-axis actually a little bit higher here. Okay, so I also noticed that number goes all the way to 50. So I'm not going to go up by 1s, but maybe I'll go up by 5s. So here's 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. All right, and my x's I'll just do by 1s. Okay, so -250 would be here. -110 drops all the way here. 0, 2 right there. And then these numbers, I can't really just guess since they're so small. I know that they're greater than 0 and they're very close to 0. And I connect. And there we go. Okay, so there is my decay function. Now I need to identify domain and range. So domain is always going to be all real numbers, okay? Because x is the number we're plugging into, so x can be anything. Range is tricky. Just simply look at your table. Notice that all the numbers are, well, right here, the number is very close to 0, right? That's a very tiny decimal, but then they're all greater than. They're not equal to, never will they be equal to. They're just greater than. So greater than 0. All right? So again, this was number 9 from the assignment you had last week. Now we're going to go over 18. 18 is a little bit more complicated. So 18 says y equals 2 times 1/3 to the x plus 1 minus 3. So this problem has a lot more going on, right? Because I'll use a different color here. I'm going to use green because it has this plus 1 here, it has this minus 3 here. So I know you're like, what is this? But remember, it's always the same. It's just like those radical equations, and it's just like the section you had before where you're going to use that to do your shifts. So if you want, ignore them for now. Just take them away. Think of just this part of the equation. Okay, so we're going to make a table of values. And we're going to use the same numbers. Okay, and again, we're only going to be looking at this part of your equation for now. So one more time, pause the video and try it yourself. Although you already did this for classwork, I know, but practice, trust me. All right, now that you're back, let's see how you did. So this should have given you 18. This should have given you 6. 0 should have given you 2. 1 should have been 2/3. And 2 should have been 2/9. Now, also something I think I forgot to mention in the previous example is if it helps, especially for plotting, turn these into decimals to help you plot it better. So this is about 0.67 and this is about 0.3. They're both repeating decimals, so we'll just use that. Okay. Now what I'm going to do is I'm going to bring back those numbers and apply my shifts. Okay, so that plus 1 in the original problem is going to turn to minus 1 for your x's. And that minus 3 right there, we're going to keep the same. We never change it. And this is going to help us to create our final table of values, which we will use to plot. Okay, so pause the video and try it. Try it yourself. Okay, so now let's see what you did. -2 minus 1, that's -3. -2, 0 minus 1 is -1. 1 minus 1, 0. 2 minus 1, 1. Now that we subtract 3, that's going to give us 15. That's going to give us 3. -1. Now, careful. If you used the decimal 0.67, you'd subtract 3, you get approximately -2.33, right? And then if you subtract 3 to 0.33, you should have received -2.78, approximately, right? Okay, so now we are done. Now we just have to make our table of values. I mean, not our table of values, listen to me, our graph, all right? So here it goes. Now, what I do notice this time, by the way, is that I do have negative values on my y, so I am going to use a portion of the y-axis that has negatives. All right? So 15 is my highest number, so I'm going to skip by, I guess I could go by 1s. I may just skip by 5s because I'm being lazy. Okay, so let's see here. -315 would be here, since I skipped by 5s. -23 is here. -1, -1 would be here, right? 0, -2.33 is here, and 1, -2.78 is a little lower. Okay, and again, I skipped by 5s. I probably should have just done 1s, because you can't really see a great picture here. But there you go. Now, when we're looking at our domain, again, domain, always all real numbers, okay? That's easy. Range is the tricky part. So my trick on range, first of all, it's always y is greater than, and always pretty much just look at this number here, the number -3. So no matter what, everything gets subtracted by 3. So when you look at your graph, you notice, let's say that this is -3, okay? Your numbers are never going to be -3 because everything got subtracted by 3, okay? Everything is going to be greater than -3. And if you look at your table right here, you'll notice too, okay? So all of these numbers are going to be greater than -3. So when the trick for range is just look at whatever this number is, the number on the outside, and whatever that number is, that's what your range is going to be greater than to. Not equal, just greater, okay? And again, that pretty much just sums up decay. We do have some word problems in this lesson that we're going to have to get back to in a future lesson. All right, hopefully this helps. Talk to you guys soon.